Welcome to the week 4 lecture. In this week, we're going to talk a lot about economic order quantity, but I also want to follow up on a couple things that we had in the last couple weeks. The first, I'm going to give a little bit more feedback on rebates and their effects on demand. I'm also going to talk a little bit more about demand smoothing. I opened up a little bit about demand smoothing last week, so I'm going to provide a little bit more context on what demand smoothing does. Then I'm going to dive into economic order quantity. This is something that you're going to be using quite a bit in the next few weeks. I'm going to go over the various variables involved, the constraints that are a part of economic order quantity, and how it's used. And then I'm going to wrap up with something fairly simple, vendor managed inventory, and its advantages. And I may have some disadvantages too. I don't know if I have any added to the slides, but there's a couple to consider. The textbook does a pretty good job of covering VMI. But I'll see if I can add a couple while we're talking. So without further ado, okay, I'm going to talk about the rebate effects on demand because we had some pretty good discussions in the classroom over rebates. Some students said that pretty much emptor caveat, buyer beware in Latin, and basically saying that as long as the terms are clearly stated and the manufacturer follows through on those, that then there's no unethical behavior. One small note, some states have laws on which rebates can be used due to what the government of that state views as unethical practices. Sometimes when you see in the fine print, the rebate is only valid in, gives you 8 or 9 or 10 states, and then if you live in these states, you have to do such and such and such. So rebates, just so you know, rebates are a very sticky subject from a legal standpoint, because even though you can clearly state a rebate and the terms behind it, there is still some legalities, and some states will allow certain types of rebate effects and not others. So just keep that in mind if you ever are doing rebates. States view it differently in various manners. So rebates effect on demand. Last week we were talking about how demand is affected by various things. And I briefly talked about rebates effect on demand last week, where I said that rebates create an artificial demand shift. And the problem with the artificial demand shift is it's artificial for 2 reasons. One, you may encourage new customers to buy products from you that they may not have before, but you may also have customers who may buy their product early. I used this last week, and this is basically comparing percentage of orders, or you can say number of orders, same thing, compared to lead time. And if you break this down into, say, each of these bars is 1 week, we have a lead time here of 3 to 5 weeks. So you have some customers that want the inventory now, before, at once customers, they want it before lead time. Then you have some that want at lead time, then some beyond lead time. What may happen if you create an incentive for a customer to buy their product earlier than expected? What happens is these beyond lead time individuals right here will suddenly shift their demand over to the at-once customers. So what will happen is you basically have a shift of your demand to the left. So in a supply chain point of view, that may not be bad, because let's say that you plan with marketing to sell 10,000 units, so you create the rebate such that you are able to encourage 10,000 units to be sold before your lead time. Let's just say that you can. Well, it'll be difficult for you to determine which of your lead time, which of your demand is new customers or existing customers. As such, it causes some confusion with your demand forecasting, because now you've biased your demand forecasting on new customers or existing customers. And sometimes you may have new customers that buy your product now, but may not buy it later, or they'll wait until another rebate exists. Or you may have new customers that just won't buy any more products. So it's very hard to differentiate between the types of customers when you use rebates. So when you use this, sometimes a little bit of sanity is required. So, oops, sorry, real quick. So when we look at, this is just a graphic, basically your demand is shifted such that your at-once customers will be increased. And what this does also, you'll suddenly have two things happen. Your demand, your short-term demand will increase significantly, obviously, but your variability within your demand increases. And if you don't forget, when you deal with safety stocks, your safety stock calculations, one of the safety stock calculations, there are several ways to calculate safety stock, but the conventional way of calculating safety stock is taking into consideration demand variability. So when you do that and you use demand variability as part of your safety stock calculations, you will suddenly see yourself creating more safety stock than you may necessarily need because you've artificially inflated your demand variability. Does that make sense? Okay. I'm going to assume it does. So feel free, if you have any questions, just type it in the window, and then I always look down in between slides or as I'm talking. So I will try to catch up with you. Now, demand smoothing is a concept that I had talked about last week briefly to discuss how to reduce the short-term demand on your supply chain. And this is used a lot. It's mostly used by large durable good manufacturers like Boeing, for instance. They make aircraft, and when they do sales, they don't plan on building all the airplanes they sell all at once. They can't, because they have capacity issues. So in areas where you have limited capacity, or you don't have a very elastic capacity, basically, for instance, if let's say Boeing can build 200 airplanes, their ability to build 800 airplanes is almost impossible. But they may be able to build like 210, 215. So that's not very elastic. So in instances where you have a very tight capacity, very tight production schedule, or if you, Toyota has done this in the past where if they find that they have a production issue, they may smooth out the demand to give them some time to catch up on repairing their capacity issue. So if you have a sudden impact to your ability to provide product to a customer, you can use demand smoothing as a way to signal to the customer, to give them options, to encourage them to delay their receipt of a product until later. Now, obviously, for certain products like groceries or short-term durable goods, this doesn't really work very well. You can't go to Starbucks and say, hey, look, I'm going to sell you a coffee, but you have to wait until tomorrow. But what you could do, and sometimes I can see how restaurants could do this. They can say, hey, look, as a matter of fact, well, for instance, at the airport, Chili's has this Chili's to-go section. They say, hey, look, if you want to buy food to go on the airplane, you can have it right now, and we'll charge you a little bit more. Or if you want to sit inside, you can sit down, we'll get you your order as soon as you can, and we'll charge you a little bit less. So that's a very simplified form of demand smoothing. And the concepts are pretty simple, okay? This is a graph again. We have lead time versus number of orders or percentage of orders, same thing really. And once again, the at-once customers, if you can tell on this graph, the number of at-once customers is higher than our capacity. On this diagram, I've added a line to signal the capacity. Well, let me see if I can get this to work. Okay. The capacity of the supply chain. So in this example, let's say that this line is 5 widgets, and we can make 5 widgets per week. So this would represent a demand above our 5 widgets per week. Now, what you could do, if you don't use demand smoothing, you could use safety stock. So if you have a demand variation of a certain amount, you can have a safety stock to cover demand variation. Now that's very expensive. And also, I don't know if you, I think I submit, no, okay, I haven't posted the announcement on customer service level yet, but when you set a customer service level, let's say if you set it to 98%, that tells you that you have a 98% chance of meeting all the demand. Now, you could go up to 99.995 or 9999%, which basically means you have a very good chance of meeting all your demand. But what happens is when you do that, the amount of inventory you use for safety stock increases. So when management creates a customer service level of 95%, using 95% as a standard, I think, but if they say 90%, 97%, what that is management's risk tolerance. So let's say if you set it to 95%, and the difference between a customer service level of 90% and 95% is, say, $10,000, okay? If your demand for that period is low, you've just spent a bunch of money on inventory that you didn't need to, okay? And vice versa, if you have it too low, let's say you set to 90%, and the demand for that point was at the 95th percentile of your distribution, you now have a shortage. So you basically either guess high on your customer service level and risk having too much stock, or you go on the low side and risk having not enough stock. So obviously that's very expensive, okay? Especially if you decide that you don't, let's say if you have a customer that won't tolerate stock outages. Basically, you have to have the stock available. So you can either sink a lot of money into inventory, or you could actually use a demand smoothing strategy where you basically tell your customer, and I've actually seen this done in technology, where you say, look, I will give you an agreed upon capacity, okay, 5 units. And for any demand above that, if you're willing to wait, we'll give you a discount on any units later on, okay? Now, of course, that does give an incentive for a company to buy their goods early, you know, basically say buy all their goods with a long lead time. But if you can structure a contract such that it reduces the risk and it reduces the amount of cost in safety stock, in many cases, this can be a good option to avoid having safety stock, okay? And just, you know, this comes from marketing. Marketing does this a lot when they do rebates and when they do coupons as a way to control the demand for products by limiting the amount of marketing that they apply towards a product. So in marketing, what they'll do is they'll say, hey, look, we only have 1,000 units, so we're only going to do enough marketing based upon, they have these algorithms that says 1,000 units of marketing costs X amount of money. So we're only going to provide X amount of money worth of rebates or coupons or whatever to maintain a certain level of demand. A supply chain can do it conversely by saying, we're only going to provide so much capacity reliably, and then beyond this, we're going to try to convince the customer to delay purchase, okay? Well, not delay purchase, but to delay receipt of a product. So once you smooth out your demand, the goal is to push your demand above your capacity beyond your lead time. Ideally, you could spread this out further and further, okay? But the goal is to at least have it so your at once and your at lead time customers are underneath your capacity bar. And that's the key thing. Now, there are ways to make this graph better. Like, for instance, what you can do is you could decrease your lead time. If you decrease your lead time, what you basically do is you shift this line over this way so that your new line would maybe be here. Okay, if we can shift our lead time from 3 to 5 to say 2 to 4, I'm trying to draw this, I'm playing with this little drawing thing here. So we can move from 2 to 4. What we've done is we have increased the amount of number of people that are in our beyond lead time. Okay, so now all these people become beyond lead time customers. And that gives us a lot more flexibility to meet our short-term demand. Okay, and while at the same time, if you reduce your lead time, especially if you can reduce your lead time and your lead time variability, that reduces the amount of inventory you have to maintain in your system. Because don't forget, when you calculate how much inventory you have to have in the system, you basically calculate how much you need for a certain period of time times the amount of time periods it takes to get the product to the customer. So, for instance, if your lead time is 3 weeks, okay, it takes you 3 weeks to get a product to a customer, and your demand is 5 units per week, you need to have 5 times 3, which equals 15 units worth of product in your supply chain. So when you reduce that, the more you reduce that, the less inventory you need in your supply chain, the less safety stock you need, and the more flexibility you have to do strategies such as this. So that's why people like to really pound on the reducing lead time. In a few weeks, there's going to be a question posed to you about what is better, reducing lead time or reducing lead time variability. We'll discuss that in a couple of weeks in more detail. So, but until then, if you have any questions on that, send me an email or bring it up during one of these chats, and I'll be more than happy to discuss it with you. All right, I'm going to erase all the stuff here. Okay. Does this make sense? Wonderful. Good. Okay, so now, various demand smoothing strategies. Reducing advertising and marketing of high demand products. Okay. I'm going to cover in a couple weeks theory of constraints about where lean is better than push strategies. Lean is a pull type strategy. Push strategies are economies of scale. And we're going to talk about high demand and low demand products at that time. So basically, the high demand products are the ones that are going to have the most vulnerable to variability. So what we want to do is we don't want to encourage people to purchase high demand products earlier, because that puts an additional strain on the capacity of a system. So you want to reduce the advertisements and marketing of high demand products for that reason. Now you could, what you can do also, and this is popular with like electronics firms that sell components, especially in the defense industry. What happens is you have, we will order like one-time purchase of circuit boards for an entire year. Now, we don't need them for the entire year, but we like to have them as a bit of like a safety stock of sorts, so that we have a high capability of having these products when we need them. What you can do is say, hey, look, I know you don't need 1 year's worth of circuit boards, but let me send you 2 months worth of circuit boards, and I'll send the next 2 months in a month from now for cheaper shipping, or for you may pay for the storage, or you may offer a discount on the items. So you want to encourage a customer that buys a lot of stuff at one time to send smaller shipments or spread out over a longer time. That allows your, when we do production scheduling, let's say if you have 6 product lines, this allows you to better manage your product lines by managing 6 small production demands instead of like 6 giant demands at one time. Like, so that you don't have to spend one whole day making one product. You may spend 1 hour making one product, maybe 1 hour spent building another product. You're going back and forth. In a lean production line, this allows you to better address fluctuations in demand for products, and also provides flexibility benefits. True, the cost tends to go up a little bit, but in many cases where lean is the best, lean isn't for everybody, but in instances where lean is the best solution, in general, we'll go over this in a few weeks, but in general, lean is good for high demand, if you have like multiple product, many product lines with a unreliable demand, lean is good for that, because if you can build a lean chain, then you can actually maintain a lot more variability. You can absorb more variability through a more flexible supply chain, but it does cost more. So we'll go through that more in the next couple of weeks. So that's a lean strategy. Offer smaller shipments spread out over a longer time. Now, offer lower costs for delayed shipping. This is something that Amazon likes to do. What they'll say, hey, look, if this product isn't in stock, if you don't mind waiting 3 to 4 weeks, we'll give you a lower cost on it rather than you paying extra money for shipping a product out right now. So sometimes for certain customers, you can provide lower shipping or unit costs as a way to encourage demand smoothing. And then offer a comparable product with a high capacity as a substitute. In some cases, if it's a product that has high substitutability, like it's something that you can substitute with something else fairly reasonably, then you can do this maybe. I can't think of anything off the top of my head, but in cases where it can be easily substituted, that's an object, that's an item, that's an idea that you can do. Okay, so just keep these in mind. So when we do pricing in a demand smoothing tactic, obviously, as I mentioned earlier, reduce lead times as much as possible. Okay, this provides you more flexibility to push your demand for your product beyond the lead time, which is what we want to do. And make shipments as small and as frequent as possible. And this reduces inventory spikes, which require liquidation. The bad thing about push strategies is it involves economies of scale. So we'll make 5,000 one item or 10,000 of one item. But what happens if you make 10,000 items and your demand is only 6,000? You now got 4,000. So now all of a sudden you need a rebate to get rid of all your extra stock. If you make your shipments small and frequent, this reduces these large inventory. Well, this reduces the risk of large inventories requiring liquidation. Okay. So keep prices as stable as possible. This is especially true of a lot of instances where customers chase prices. You've probably seen this a lot, where people will wait for a sale to buy something. Well, if you have a pricing strategy and you have dynamic pricing and you're chasing a demand and the customer knows it, you can inadvertently shoot yourself in the foot. And this is where I think I gave some students feedback on this, where although there is a correlation between demand and price, if the product has high demand, you could charge a higher price. That is generally true. But in instances where we have delayed lag, where you suddenly, like earlier, when you have high demand variability in your forecast, you suddenly detect a large demand and you create a whole bunch of product and you've satisfied that demand, your dynamic pricing model will say, oh yeah, drop the price down. But when you do that, the customer's gonna get smart. They're gonna say, oh wow, the price for this thing that I spent 10 bucks on last week is now $5. So all I gotta do is wait a while and I can get it for half price. One of my hobbies I like to do when I'm back in the States is I'll go to like Burlington Coat Factory or Ross or Marshall's, companies that excel at liquidating excess stock. And it's amazing how you can see this take effect. You can see, like, you know, previous product lines where they made so much. And you could see, you could kind of get a picture for how this takes place with certain product lines. So that's just something I like to do. It's just one of my hobbies. Okay. And then allocate products in the supply chain based on past orders, not present demand. This goes back to the artificial inflation of your demand variability. If you start to chase demand on the short term, what happens is when you provide your rebate and you have that sudden demand influx, you'll suddenly see this huge spike in demand. And if you don't change your demand forecasting model, you will use that erroneous data from your recent demand to calculate your demand forecasting. Yes, historical data, exactly. So, like, for instance, this is especially true in a lean supply chain where you have to have very accurate demand forecasting. In lean supply chains, they like to say that they don't use demand forecasting, but in reality, you have to use something, because you can't, we're not in Star Trek times where we can just teleport stuff from A to B. So you always have some lead time, okay? But what you do is if you create the instance so that your lead time is as short as possible, you have a little bit more control over your demand forecasting. So let's say that you have a huge rebate, and you know that you had a huge rebate, and you get this inflated demand. What you would do is you don't use present demand, because your present demand has been artificially inflated, okay? So you may use more, you may discount the recent historical data. You may say, okay, we're going to create our demand forecasting based upon non-rebate data. Or if marketing has a very good model to understand where that demand came from, they may change the historical data to reflect, to like smooth out the actual demand, which is very difficult. There are algorithms that do this. I've heard of them, I've never used them. But in general, you don't want to use your most recent demand in your demand forecasting if you've influenced it by things such as rebates or coupons or anything that'll artificially change the way the consumers use your product. Does that make sense? Wonderful. Okay. And that's a very important point, because I see all the time where they say, yeah, we're gonna keep, we want to use the most recent demand possible. So, and this is something about VMI. They say, yeah, you're able to share demand data throughout the supply chain, but if your demand data has artificial fluctuations and everyone has the wrong demand data, you may be causing more problems than you solve. So just keep that in mind when we talk about VMI. Now, economic order quantity. This is a very important concept. It is important not because it's extremely accurate, but because this provides us a model to determine an optimal purchasing lot size, which allows us to make certain types of decisions, okay? I've rarely seen people use EOQ exactly as it's stated, because there are some assumptions that you have to consider. But for the most part, it provides a good barometer for you to start figuring out what kind of lot sizes you're going to use. And this is important because later on, when you design a supply chain, you're gonna have to figure out what lot sizes you're gonna need to determine what kind of storage you require and how much manufacturing capacity that you're going to need to maintain this lot size, and how much product your suppliers are going to have to provide to maintain a certain lot size. And all these calculations include things such as holding costs, total costs, fixed costs, variable costs, all kind of, transportation costs, which are a form of, I guess it could be a fixed cost per unit. Well, it would be a variable cost, sorry. So it's a good start. So There are several assumptions that economic order quantity uses. These are the main ones. There may be some smaller ones that I haven't read about, but these are the ones that I've either found in textbooks or found in reading, or ones that I've used. And there's 7 main ones. These are the main ones that we deal with assumptions. When I deal with models, I always tell people, when you create a model, you need to understand the assumptions and the constraints of a model, because when your model goes wrong, you got to go to these assumptions to figure out which of these assumptions were wrong. Whenever I use models to make decisions, I always reality-base my decision based upon the assumptions in the model. Every model has assumptions. That's just the way they're built. Okay. I'm not going to go into a lesson on models, because I can probably do that for an hour, and I don't want to bore you to death. But just remember that when we deal with models like economic order quantity, just remember the assumptions. You always have to remember these assumptions, because when you use these in the real world, you got to test these assumptions to see what the likelihood of these assumptions becoming true is. So the 7 of them, you have a known and constant product demand. When we do EOQ as it is here, we basically do not vary the demand throughout a certain time period. Because if you do, then you got to change the equations, and it gets a lot more complex. You can do it, and there's software that does it for you. Or you could create multiple EOQs with smaller ones based upon each of your legs. But for the sake of this class and for the sake of most real world scenarios, we just make it known and constant product demand. We have a known and constant lead time. So we're going to make believe that lead time is known and it's constant, does not change. Obviously, you can see a problem with that. But so in theory, the more stable your lead time, the better EOQ is applied. Now you've got one price per product regardless of the quantity ordered. This is important because, like I think we've already had a problem where there was different levels of pricing. Yeah, it was in one of your self-examinations where it gave a different price based upon the quantity ordered. Once again, there are models that will take this into consideration, and they're very complex, and they're usually software-based. But for the sake of learning EOQ, we're going to assume there's one price per product, regardless of the quantity ordered. And all units are received all at once. So if your EOQ is 50 units, you receive all 50 at one time. This is important because when you do holding costs and total costs related to the inventory, we calculate it based upon the lump sum of all of them. So we also are going to assume that the same quantity is ordered at each reorder point. We're going to cover reorder point calculations later in this class. I'll go into that more detail. But in the real world, you may have instances where you may change the quantity ordered based upon demand. If your demand slows down, you may order less. Certain supply contracts will allow you to do this. We are going to assume that the same quantity ordered at each reorder point. So if we make this EOQ for a year, the same quantity will be reordered at each reorder point regardless. Okay. Ordering and carrying costs are certain. You know the ordering and carrying costs of all your orders. Once again, you may not always have that, because you may have things like transportation costs or other factors that may influence the actual costs of getting your product to the supply chain. And no stock out costs. Later in the week, we're going to deal with stock out costs. Now you got stock out costs, and then you have stock out from excessive stock. So we're going to assume that there's no cost of not having stock, and there's no cost from excessive stock. Later in this class, we're going to deal with salvage costs. So stock out costs basically is a cost of not having enough stock on the shelves. Then we have salvage costs, which occurs from excessive stock, which is our need when we have too much inventory and we have to basically sell it through Ross or Burlington Coat Factory or Marshalls, whatever, for just to salvage some of our costs. And we're going to talk into contract vessels, how we're going to do that. So we are going to assume that we aren't going to take any of that into consideration. So if you look at the EOQ model, the EOQ model is a point where the holding costs and the ordering costs meet. Holding costs basically is a linear line, okay? And this is a per unit cost to hold an item, all right? So that's one of our assumptions. Holding costs are certain and they don't change, and constant. So it's a linear relationship. The ordering costs, it could be linear, but generally the ordering costs, the more you order, the lower the ordering costs. So the EOQ, the optimum amount that we're going to order, is a point where these two graphs meet. And that's what this calculation that we're going to do tells us. So when we calculate EOQ, there's three like sub-calculations that we have to calculate with it. So EOQ is not just one number, but it's also a set of calculations. The first one is the annual material costs. So it's an annual demand times the material cost. It's fairly simple, okay? So if your annual demand is 20,000 units and the material cost is $1 each, is $20,000. It's very simple. So now the annual ordering costs is the number of orders per year. And this is basically the number of orders divided by the order quantity, by the number of orders per year. So if you have 10,000 units that you're going to be buying during the year and you have 10 orders, that number would be, let's see, 1,000. So 10,000 divided by 10 would be 1,000. And you multiply that by the ordering costs. So it's R divided by Q times K. So the ordering cost is the amount, is the cost per order. So it's fairly simple. So the number of orders per year, which is the total number of units needed divided by the number, by the quantity of orders, by the order quantity. So it's, I'm sorry, I think I may have misspoke. By how much in each order. So in the previous example, if we had 10,000 and each order quantity was 1,000, then we have 10 orders per year. So that'd be 10 times the ordering cost, whatever the ordering cost would be. So forgive me for that slight misread. It can also be calculated as basically the annual demand divided by the order quantity. So the annual demand is 10,000, the order quantity is 1,000, that's 10 times ordering costs. So then you have annual holding costs. So once again, it's the average inventory level. And this is, I want to take a little bit of time to explain the average inventory level. And basically it's Q divided by 2. And then multiplied by the holding costs. So if we look at the amount of inventory, don't forget, one of our assumptions is that our consumption is steady. Okay, there's a steady demand. It doesn't change. So if you take any set of numbers and you go from say 10 to 0, and you average all those numbers out, it's going to be basically the highest number divided by 2. Okay, that's going to be your average for all your numbers. Okay, so we're going to take that number times holding costs. Does that make sense? Wonderful. This is very important because a lot of students get confused on that, the whole average inventory level problem. You just have to remember that we assume constant demand. So when you have constant demand, you take the high level and you divide it by 2. And that's your average demand, average inventory level. Then you multiply that by your holding costs. That's holding cost per, per unit. Okay. Once again, this assumes that we have constant demand. Obviously, if you have spiking demand and decreasing demand, you know, your ability to just divide Q by 2 decreases. But for the sake of this model, it works great. When we calculate reorder points, it's going to use the exact same assumption too. So EOQ model. This is the EOQ model. It looks kind of complicated, but it's not that bad. So Q, which is your EOQ, equals the square root of 2 times your demand times the ordering cost per purchase order divided by the carrying cost per unit. You put all that together, and that gives you an EOQ. So with those other calculations that we had here, this number is the amount, that's the optimal order quantity. And you include this with these 3 values, and that gives you like a bunch of data that we're going to use to determine inventory in general. You're going to be using this in week 7. It's a very, it can be confusing. It's a confusing problem. I have a lot of videos I'm going to upload, and I usually have a special session for week 7 to go over that problem. But if you can get these 3 concepts down and this EOQ equation, you'll be doing very well. You'll have the lion's share of this problem taken care of. Then all I got to do is just walk you through the different parts of the problem, and you'll be able to figure it out fairly simply, I think. So, all right. So now we're in the home stretch. VMI. VMI, in general, is a system in which the vendor controls the inventory going through the supply chain. So they control, or they have control over and insight into the amount of material from start to finish. And one of the benefits of this is that since the vendor immediately sees the demand for the product, so they reduce consumption reporting time by making their demand history available to everybody in the supply chain. Now, this is a great concept in theory, but what happens is a lot of these players don't like to be told how much they have to produce. Like, for instance, VMI, when Walmart does VMI, they say, hey, distribution or manufacturer, we need you to make 20,000 units and we need you to have them ready within this time. And they'll say, well, why do you need so many? Or why don't you need so many? They lose a lot of control over their ability to control their own operations. And a lot of companies don't feel comfortable doing that. Okay. This also takes away a lot of the incentives from people like distributors. Distributors have a very interesting role within supply chains, in that in the old days, there used to be a valuable link between a retailer and a warehouse. But since we've shrunk supply lines, distributors are more of a link for retailers to multiple different warehouses. Well, if a vendor has control over the demand, they're doing basically the exact same thing that the distributor is doing. All they got to do is create their own network of warehouses. So in the old days, when a distributor controlled the number of warehouses that products go through, a VMI, they would have their own warehouses. They'd say, well, distributor, you really don't have a valuable role within a VMI. So as a result, I've talked to several distributors. They've had to change the way that they view distribution. This slide should say manufacturer, by the way. I need to change that. So a VMI on paper sounds great, but it really sometimes works great, sometimes it doesn't. It just depends on the kind of relationships within the parts of the system that the VMI is a part of. So here's the advantages. Reduces the number of purchasing, inspection, and storage functions. This is important because if VMI provides all this information, each of those entities don't have to do this. They just get the data from the VMI. The supplier gets visibility on the rate product is being consumed. So they have all this information on the product characteristics as it relates to the customer. They also get replenishment rate information, and it also allows suppliers to prioritize their shipments better by reducing bulk buying tendencies, because the vendor is more engaged with the supplier to say when they need items better, so they can prioritize which shipments need to go where better. And an important part of this is it virtually shortens the supply chain. In week one, we had kind of seen how a long supply chain can cause ripples throughout the supply chain when it comes to things like variability. When we share information within the supply chain, we actually shorten the supply chain by sharing information through everybody. And if anything happens, like we have shortages or planned promotions or inventory level problems, the entire supply chain knows, and as a result, everybody can get together to fix the problem. Okay, and allows for even more allocation of inventory. Okay. So now the weaknesses, and I already mentioned most of these. Suppliers can encounter resistance from marketing, because if you have a VMI, you have fewer events of excessive stock. Marketing usually has incentives to move stock. That's their job. Their role is to encourage demand of products. Well, if the VMI has more control over the products being sold, they don't have to worry about having marketing sell certain stocks, because the VMI can do that for them. So when you run a lean VMI where you have low inventories, a lot of people like distributors and even suppliers, they don't feel very comfortable with low inventories. Although it makes sense in theory that low inventories means lower costs, they don't get comfortable. So what happens, you'll have instances where the manufacturer will create more inventory on their own. So they end up bearing more costs, because Walmart says, hey, I only want so much demand, and anything above this, that's your fault. And we're going to talk about certain types of supply contracts that do this. And Walmart is famous for browbeating their suppliers this way. Just make a note that just because you have less inventory throughout the supply chain doesn't mean that people are really comfortable with that. Distributors may lose control over the distribution. Like I said before, there's no use for a distributor if the vendor is able to control the distribution for them. Especially if you're like Walmart and you have a warehouse system set up and you don't have a 3PL. Modern day distributors have a 3PL component for that reason. But if you're like Walmart and you have your own 3PL, well, it's not really a 3PL, obviously. If you have your own logistics, and you have your own warehouses, then you don't have a need for a distributor. Toyota takes a different approach, and I'll talk about that in a week or two when we talk about distributor strategies. And inefficient modeling can produce inventory shortages. As I mentioned before, let's say you have rebates and you artificially influenced your demand, and the vendor goes, here's the new demand forecast, and everybody build to this. And if everyone builds to a bad forecast or a bad model, everybody is going to get affected badly. So although that's rare, the opportunity when a VMI fails, it fails really badly, because everybody in the supply chain becomes more vulnerable to inventory shortages, or, I guess if you build too much too, I guess. So that's a really quick discussion on VMI. The book does a pretty good job of it, but if you have any more questions about VMI, let me know. Is there anything else I can cover that I did not go over? The alternative to VMI. Well, the way that we're going to talk about supply contracts. We have build to stock and build to order. Okay, so I'm going to give you a quick teaser on this. If you have a build to stock strategy, it basically says, supplier, you need to build to a certain level of stock. Okay, we always want to have 50 units available at all times. So all the supplier has to do is build a certain level of stock. Now, build to order says, okay, in a build to stock, the risk is on the manufacturer because they have to make sure that a certain level of stock is always available. You have a build to order strategy where build to order says the vendor places a certain order, and manufacturer does not do anything until that order goes through. Then they build to that order only. So all the risk is on the supply, is on the vendor, because the vendor is the one that's responsible for putting in the order. So in a build to order strategy, the vendor has all the risk and they're responsible for setting the amount that is ordered. In a build to stock, manufacturer has to maintain a certain level of stock. So if the contract says you got to always have 50 units of stock and the demand is 10 or 15, they got to basically chase that demand. So the risk is on the manufacturer because they have to basically ride the demand to make sure that certain levels are available at all times. And these are all contract driven, and these are related to way, like push strategies and pull strategies use certain ones, but generally a build to order, build to stock. A VMI uses these, but the VMI is more like real time. If you don't have a VMI, then the inventory is managed using either one of those supply contracts I just mentioned, build to order or build to stock. Or in some cases, a distributor will do that. This is more traditional supply chains, but they're still around. The distributor will say, hey, supplier, we will provide a certain level of stock for you. We have multiple warehouses or manufacturers to pull from. So you have distributor inventory controls also. Okay, does that make sense? Yeah, it ties into I think what was week 2. This explains concept a little better. Okay, yeah, what was, I'm trying to think week 2. Did we cover VMI in week 2? I don't think we did, but maybe there was an introduction to VMI in week 2. But yeah, so we're gonna talk about build to stock and build to order a lot more in a couple weeks. You got a whole week of this build to stock and build to order. There's all kinds of problems. Oh, build to stock, build to order a little bit, yes. Okay, we covered build to stock and build to order a little bit, yeah. I think I just gave it to you as a teaser because the problem that I've seen is students, as early in the class, they begin to have problems where they need this information, but they don't get the information from the textbook until later in the class. So I try to give a little bit of more information earlier on to help you guys build upon it. And sometimes, because I'm trying to cover a week worth of information in a 20-minute soundbite, I always fear that some things fall in the cracks. So yeah, so we'll be covering build to stock and build to order more later on, but because you're going to actually create contracts. Well, you're not going to create a contract, but you're going to work on scenarios that deal with build to stock and build to order. Sometimes you hear it called make to stock and make to order, same thing.